Hello guys, welcome back to class. In this session, we will see the introduction part. Still we have something to complete. So what we have seen in the previous session? We have installed Java. This is day 2. So what we have done in the day 1, we will do quick revision and then we will go to day 2. In the first session of day 1, we have seen how, or you can say what happens when you run C program internally. Then we say what happens when you run Java program internally. We understand how processor works. Also understand how RAM is utilized. And we have seen why C and C++ programs are platform dependent. And then why Java programs are platform independent. So these things we understand. So we understand why C++ are platform dependent and Java programs are independent, right? Based on this, can you answer the question, which program is faster? Which program is faster? C program or Java? C or Java? So you're selecting both the answers. Some are telling C program, some are telling Java program, means still you didn't sync. You didn't sync with my mind into my flow. If you sync, you will give only one answer. Okay, have a look. Actually, answer is C program. Still, till today, C programs are the faster. Why it is? You only see. I'll explain, then you answer which is the faster. In the case of C program, first you're writing hello.c, which is the containing a source code, right? Then you're compiling, you're getting hello.exe file. So now you are running. What you are running? You are running the exe file. You are running the binary code, right? This exe file contains the binary code. This C program contains the source code. So when you run, you are running directly the binary code available in hello.exe file. You are running the binary code available in hello.exe file directly. So whatever binary code is there, it starts running immediately, right? But in the case of Java, what happening? You are writing hello.java first, and then you are compiling. You are getting hello.class file, right? Now, your .java file contains the source code, and hello.class file contains the bytecode. Bytecode is also called as a magic value. Magic value. Bytecode is also called as magic value. So you are running the bytecode, right? In the case of Java, you are running the bytecode. What happens when you run the bytecode? What happens when you run the bytecode? What happens when you run the bytecode? We discussed already, guys. What happens when you run the bytecode? No, Pavani. exe will not be generated in the case of Java. We tested that. Copying to main memory is anyway common in both. Leave that. But here it is spending a time. First it has to convert. It has to convert your bytecode to binary code. Convert bytecode to binary code, and then execute binary code. In the case of C, directly executing binary code, right? Because binary code is readily available for us in the case of C. In the case of C language or even C++, in the case of C language or C++, your binary code is readily available. So directly it is executing the binary code. Immediately binary code will be executed. But in the case of Java, first it has to spend some time. It has to spend some time to convert your bytecode to binary code, then execute. So extra time it is taking to convert your bytecode to binary code. Let it be 1 millisecond only. Let it be 1 millisecond or 0.001 millisecond. Whatever the time, some extra time it has to spend, right? One side, directly binary code is readily available. It executes the binary code immediately. That is C, C++. Java case, we have a bytecode. We don't have the binary code at all anywhere. So first it has to spend some amount of time to convert your bytecode to binary code. Then binary code execution happens. So it is taking extra time for conversion of bytecode to binary code in Java, right? Now tell me which is the faster? Now tell me which is the faster, guys? C programs, C++ programs are faster than Java. Very good. So this is what we understand in the session 1 of day 1. Day 1, session 2. We started installing Java. Java installation. Then understanding path. Why we need to set a path? There are 2 points important. I'll write clearly. Why to set path? Tell me. Why to set path? Why to set path, guys? Why to set path? Very good. To access not all the files, Naveen. To access exe files or binary files, you have to use the sentence to access .exe files, also called as the binary files, because exe files contain the binary code, right? So binary files I am saying. To access exe files from anywhere in the computer, you have to set a path. And how to set a path? There are two ways. You can set temporarily, you can set permanently. There are two ways to set a path: temporarily and permanently. So whatever we discussed is permanent way. In the system environment variables we are setting, right? System environment variables, whatever we are setting, I showed in the previous session, that is a permanent option. Once you set, it will be there permanently. Even when you shut down system, it won't go. Temporarily, you can set at command line also. You can set the path at command line also. If you want to set at command line, you can say set path equals to %path %, means you are telling take the existing path, whatever current path is there in system, take that plus concatenate my new path. What is the new path you are adding? Which files you want to access, across the computer? Currently, I have some files in bin folder of JDK. I have E drive. Under that, JDK 8.0 folder is there. Under that, bin folder is there. So under bin, I have some files, exe files like javac.exe, java.exe, etc. So whatever exe files are there in this bin location, in this JDK bin location, those files I want to access across the computer in all the locations of the computer. So this you have to add it to existing path. So this is you're taking %path means you're taking existing path plus this new path you're adding. So whatever available in this, it will add to corresponding path. But if you set like this in the command line, you can do this in the command line. Like this, anywhere you can set this. This is temporary actually. Whenever you close this command line instance, if you close this command line, then whatever path you set, it will go. So that is only temporary. Permanent is system environment variables. So we understand this. Then we have written a steps to write, compile and run the Java program. First Java program you have seen, right? And we played with many options, like how to compile. Tell me guys, how to compile the program. How to compile the program? You are using Java C. Banu Prakash, very good guys. Banu, Sandhya, Harishankar, Pavitra, very good. Java C space. After Java C, you have to give a file name. Give a file name .java, you have to specify. Right? Now, whatever the file names you are saving, you can use that. And remember one point, file names are not case sensitive. Notice, file names are not case sensitive. What it means? Take our command prompt. So we have hello.java, test.java. Currently, you are seeing two files. Am I right? Two files are there. Okay. Now, when I'm compiling this, let me to open hello.java one time. Yes, this is my simple hello.java. Okay. In this case, I've taken the same file name, same class name. When I'm compiling the Java-C file name, I can give like this. This is actually how you are giving, right? Compiling. Now, as I told you now, case sensitive, not case sensitive. Can I give H small here? Can I compile as Java-C space H small? Okay. You read my point here, guys. Come back to this. File names are not case sensitive. What is the meaning of this? File names are not case sensitive. You can use a small, capital, anything. File names are files you are saving in the hard disk, which is managed by operating system, file system. OS has a file system, right? OS one module is file system, right? So file system handles this. There's no relation with your Java, JVM, anybody. So file names in your hard disk managed by OS file system are case sensitive. You can use small or capital, no problem. It means if I have a program H capital, hello.java, you can compile, no problem. Guys, you can also do like this, no worries. Existing .class files I am deleting. See, compile successfully. Del star.class. Okay. Now you compile it. Java-C, H small I am giving. No problem. It compiles. Now, when a .class file generated, what .class file will generate? H small will generate or H capital will generate? H small or H capital, guys? .class file, what it comes? H small hello class will come or H capital? .class file is not related to your file name. Am I right? Any relation between your file name and .class file name? There is no relation. File name is extremely different. Your .class file will come based on your class name. .class file will come based on your class name. .class file will come based on your class name. Your class name is hello H capital. So .class will come with H capital only. Okay? Very good. Next. Now, how to run the program? Java space. How to run the program? Java space class name. Very good. Java space class name. Java space class name. And what is the condition here? This class name you are specifying. The class name must contain standard main method. Standard main method. It must contain the standard main method. Okay. So I have a hello.class. I can run now space hello.java space hello. My question to you guys, can I run as Java hello, H small now? This is Java class, right? This is Java class. No relation with your file system, operating system. Only files handled by the OS file system. This is my Java class, relation with my JVM, right? So here, the point to take is Java class names are case sensitive. Java Class names are case sensitive. If capital hello class is there, you have to call that as capital hello only. When you do that, then only it will run. Run this. You are running successfully. Okay, do small. It will scold you. It's telling simply, sorry guys, I don't have the class called hello. It is checking for a class with the H small. Do you have that? No class. So it's giving error, I don't have this class. Could not find or load a class hello. Class hello is not there. Class names you have to take as this. And already we discussed the questions, other important questions as, so can I take different name for file and class? Already we discussed. Can I take a different name for file and class? Yes, very good. We done experiment also, right? Okay. Next question. Can I have multiple classes in one source file? In one source file, can I have multiple classes? Very good. Yes, we already tested this, right? Now, one more question, guys. Can I take small case for class name? Can I take small case for class name? What is my intention is this. H small I'll take here. Can I take hello H small? So all are not accepting. You're all telling no only. Okay, I'll ask compiler. What compiler is telling, that is the final. H small I've taken. And source file is H capital. Source file is H capital. See that again carefully. Java C hello.java. Source file name I taken as H capital. Compile successfully, guys. Compile successfully. Compile successfully. Let me to delete the .class files once. Whether it is saved or not saved. Del star.class. Sandhya is telling some point. Okay. So currently I have taken H small. What happened? Compiled or not? Answer is, can I take a small case for class name? What is the answer? Yes, guys. You can take. Who will stop? Now when I am running, how to run this? How to run this program? Java, you write a small hello only. Yes, now actual class name is small hello. You have to run as small hello only. You have to run as small hello only. Yeah, hello guys. If you run with a capital hello, very good. You got the point now. So this is error. And this is okay. And on this top, I'll take one more here. If I have hello as a class name, H capital means Java hello you have to write. This is okay. When class name is H capital hello, I can't use as a small. This gives the error. So can I have a small cases? Yes. But Compiler, no objection, guys. It is like, say, I am going to advise you that, my dear students, don't waste your time. You study well. You spend more time for study. What is that? Is it advice or mandatory? I am telling a good advice. If you study, you will get a job. If you get a job, you will get a salary. If you get a salary, I won't get anything. If you're not getting salary, I won't pay anything to you. Advice is that, recommendation that study well, do well, right? If you follow recommendation, you will be happy. Similarly, in Java class names, you take whatever you want, no objection. But recommendation guidelines, you say coding practices, you call it as a best practices. Best practices you must follow. When you are practicing, you take anything, nobody will ask you. But when you start working in the company, you have to follow the coding guidelines. Whenever you write the code, you have to follow some best practices. Those guidelines has to be followed. You must follow. If you are not following, compiler will not object. But maybe your team lead will say, your manager will say, why you are not following guidelines, right? So class names, when you take the class names, what is the practice to follow, guys? Every word, first letter must be capital. That is a best practice. Every word first letter must be capital. Suppose you're taking hello, you take hello H capital. You're taking a student class, student S capital. You're taking customer class, C capital. Suppose you're taking a student number, then what to do? Student is a one word, number N capital again. Two words are there, every word first letter capital. Okay. Now I am taking student phone number. Maybe class I am taking intentionally bigger. Student phone number. Student one word. Phone another word. Number another word. Every word first letter is capital. Suppose I may have a bigger class name, something like this. Student primary phone number. Primary phone number. Student one word, primary, second word, phone, third word, number, fourth word. Every word, first letter, capital. These guidelines you have to follow always. If you are not following, what happens? Compiler will not give any objection. Compiler, whatever you give, suppose if you give the class name small hello, it will compile it. When you're running, you use this. But coming to the coding guidelines, you have code review concept. Code review by your team lead or senior people will do that. Whatever code you're writing in the project, that will be reviewed by somebody. So a code review, you have to follow some coding standards. If you violate any of the standards, your manager will scold you. If you do repeatedly, they'll throw you out of company. Clear, guys? Now, from all the discussion points, one more question. Is it mandatory to write main method in the class? Is it mandatory to write main method in the class? Is it mandatory to write main method in the class? This also explained. Answer is no. Answer is no. Not required. See, I'll do. I'm writing my test program. I shown this, I think. I have my hello class. In this, I have my, in this just show method is there. Hi class, I'll take something. Display method. Hello class, show method. Hi class, display method is there. It will compile but will not run. I didn't ask you I'm running or not. That is the context. That's how you deal with the interview, guys. That's how you deal with the interview. The intelligent answering is what I asked. What I asked. I am writing a class. In the class, main method is mandatory. Not required. That is how in interview they'll ask like this only. You can answer it only when you are so confident on the technology, so confident on the concept. Any method, any class you write, main is not mandatory. Now, same question I'll ask in different way. When main method is mandatory, when main method is mandatory in the class? Exactly. When you are running the program, right? When you are running the class, when you are running, then only that class must have main method. Only that class must have main method. Generally, in an application, when you develop a project, you may have one class as a main. That is, when you're running Java space class name hello you're writing. Now, only when you're running like this hello class must have a main method. Otherwise, other classes not required. Okay? But why not required? How to use if classes not main method is not there? We will see anyway. We'll write thousands of classes in our course. Thousands of classes will write in our class. Maybe one file, one class will write with the 500 lines also. Bigger code will write. We'll learn it. So these are the basic things, right? Now, so one last question from the previous connection. We will start a new topics then. This is I will do, guys. What happens when I compile and run the following code? Class hello, capital I've taken, following best practice, cool, and static public void main string args. Something I written. I don't know what happens. You have to tell me. Can I do something like this? You're trying all the combinations, right? Permutations and combinations you're trying. See this code. I'm trying to compile. Class hello, static public. Cool. Compile this Java C hello.java. Compiled successfully and also executed successfully, guys. No. Order can be anything, guys. Come back here. Take the point from this. The point is, whenever you write a method, any language, any programming language, whether it is C, C++, Java, Python, JavaScript, whatever programming language you take, method signature is this. Method signature, you write a method name. Then parenthesis, you write some arguments for a method. Before method name, you will write a return type. Here return type is void. Okay? Void. Some return type. If it is returning something integer, and we will explore more about method. This is a basic signature of method. Return type first, then method name, then parameters, method opening, curly braces. You write any lines of code you want, close the method. This is a standard for a method signature. Okay? And in this method declaration line, first return type, then method name, number 3 parameters. Okay? Then other modifiers you are applying for this. Other modifiers applying for this. You apply any modifiers. What are modifiers? Like we are seeing public, static, final, synchronized, native, abstract. There are many modifiers in Java. We will learn on the way. Currently, 2 modifiers applied for the main method. What are 2 modifiers applied? Public and static. Why these are mandatory, we'll talk later. Currently, we don't know public, we don't know static. Still, we are at learning alphabets, right? So, order of modifiers can be anything. Order of modifiers can be anything. So, you write this as public static, static public, no worries. This extra modifiers attaching for a method can be anything. Yes, it is a modifier, access modifier or something. Currently, a modifier Naveen. It is a modifier, right? Order of modifiers can be anything. So, write public static, okay. Static public, okay. Void means returning. Method returns nothing. It means nothing. Void means nothing. That more about method we'll see. Yeah, it is returning nothing. Right? And if you add extra modifiers also, it won't give any trouble. For JVM guys, it needs public static. 2 modifiers required. Order can be anything. And if I add extra modifier, for example, I will be adding extra modifier final. Extra modifier final. Any objection for JVM? No objection. Public static there or not? Yes, public static there. JVM happy, it will run the program. You apply one more. Currently, you don't know final. We'll talk. Synchronize something, most important topic. I added some extra modifier. No objection from JVM. Synchronized will add some extra meaning. And that doesn't stop your program execution running. Final makes some extra meaning for that we will talk later. So these are the how many modifiers applied for my main method now? I applied 4 modifiers: synchronized, final, static, public. You apply any number of modifiers, no objection for JVM. JVM needs only 2 modifiers, static, public in any order. Similarly, these modifiers, 4 modifiers I am using. These 4 modifiers you apply in any order. You write public, static, final, synchronized, static, public, final, any order you write. No worry about modifier order. So if you do this also, this program will run. No problem at all. I'll be adding one more question on this. Just compile this. Compile successfully and executed successfully. Add this question also. What happens to the following program? No problem. Synchronized, final. No, I want public, static. There or not? Yes, there. No problem. Right? Okay, guys. I think that's what we have discussed some points and added some more points. Now, from the discussed points only, I'll be asking the questions like, what is a source code? What is source code? Is it a machine understandable or human understandable or JVM understandable? Human understandable code, correct. Human understandable code written in high level programming languages. Very good. High level programming languages called as source code. When I attend an interview in Sun Microsystem, maybe in 2002, 2 or 3, I forget. When I attend an interview in Sun Microsystem, after completion of my MSc Computer Science, I done this, that, and I attended first interview, some interviews attending, and when I went to Sun Microsystems for interview, first 3 questions asked me. First 3 questions. First question, what is source code? Second question, what is bytecode? Third question, what is binary code? They didn't ask binary, what is native code? These are the first 3 questions they asked. And later they asked many. First 3 questions are those. What are high-level programming languages? Like Java, C, C++, Python, Scala, Kotlin, Go, many high-level programming, JavaScript, these are all high-level programming languages. So human understandable code written in high-level programming languages, like otherwise high-level programming languages like Java, C, C++, Python, Go, etc. is called as source code. Okay. Second question, what is bytecode? What is bytecode then? Intermediate code. Very good, very good. Harishankar, Pavitra, Pavani, Monica, Alekya. Low level, no, not low level, Alekya. Nabeen, you're right. The sentences I'm framing, you remember by heart, do whatever, it should be registered in your mind. You have to come in that flow. So who will understand this JVM bytecode, guys? JVM only JVM can understand this. JVM understandable code. It is not written, right? You are not writing. JVM understandable code, then generated by Java compiler. Generated by Java compiler is called as bytecode. Is called as bytecode. JVM understandable code generated by the Java compiler is bytecode. Bytecode has another name. What is another name of bytecode, guys? Bytecode is also called as magic value. No, not native code, magic value. Native code is different. Native code is different, guys. My next question is that only. What is native code? Then native code is the binary code, right? You can write the answer here as native code is all. First you tell me native code definition. What is native code? Who will understand native code? Will you understand native code? Machine understandable, processor understandable. Very good. Machine understandable code generated by compilers or interpreters is called native code. So why I'm calling as native code, I'm saying generated by compilers and interpreters. The reason why I'm using 2 words, compilers and interpreters, is depending on the programming language, guys. In the case of Java, if you see bytecode case, I told clearly as bytecode is JVM understandable code, which is generated by Java compiler only. Whether C compiler will generate the bytecode, whether C compiler generates the bytecode, whether C compiler generates the bytecode. No, that's what only Java compiler generates. Clearly I have written bytecode is a JVM understandable code which is generated by the Java compiler only. But coming to machine code, native code, I am telling native code generated by either compiler or interpreter. Either compiler or interpreter. The reason is in the case of C language, who is generating? In the case C language, who is generating machine code, guys? C language. Take a C language. In a C, who is generating native code? C compiler. Compiler is generating exe file, right? Fine. But in the case of Java, who is generating native code? JVM only, but we have interpreter internally. We have interpreter or JIT compiler is there. We have interpreter or JIT compiler is there. And if you go to Python, I think somebody referred there. Python interpreter they may use. Or if you go to very old language, basic language name is basic only. That has an interpreter. So different languages having compilers, interpreters to generate the native code. That's what anyone, either compiler can generate native code or interpreter can generate native code depending on the programming languages you are using. So clear? Fine. Now what are other names of aliases for this? What are other names of native code, guys? Native code is also called as, very good, binary code, or one more term is there, mission code, right? Mission code. Yeah, it is in a language called mission code is based on the low level language. Yeah, there are programming languages you can divide into three categories. Programming languages are three categories. What are low level programming languages, and middle level programming languages, and high level programming languages? Low level means binary code. Middle level means assembly language. Assembly language, maybe you heard or not, I don't know. Assembly language. High level, you know this. C, Java and all that. Okay. And we also already understand about Java platform. Why? And here I need one more point to add. Your native code or binary code, I will use the common word binary code, guys. Further, I'll use the most important sentence when I'm explaining. I'll use a term binary code. See, binary code is platform dependent. Platform is the same sentence I am repeating. Binary code is OS dependent. Am I right? Binary code is what next? One more dependent is there. Processor dependent. Very good, guys. Processor architecture dependent. And why it is dependent, I shown with the diagram in the previous session. Coming to the bytecode, we'll add these sentences also. Bytecode is platform independent. It means bytecode is OS independent, and bytecode is processor architecture independent, you can say, but it is depending on bytecode is which dependent. Any dependency is there for bytecode? Ah, wonderful. Is a JVM dependent. If JVM is there in that computer, enough. Irrespective of the underlying operating system you have, the processor architecture you have, no worries. If JVM is there, my bytecode will run anywhere in the globe. Right? Very good, guys. Now, so we have two more things to understand. Java interpreter is there. This is the older, in the older versions, compared to C and Python, C only faster, Sandhya. Python also we have a similar bytecode mechanism actually. Python also we have similar bytecode mechanism. So Python also it takes again bytecode, first bytecode only will be generated in the Python also. So the bytecode has to be converted to native code. But in Python, there is a mechanism that you can initially only we can generate the two styles are there in Python, depending on the tools you are using. In Python, you can generate first bytecode. Then when you're running, bytecode will be converted to native and run like a Java. Or there is a kind of concept where first you bytecode generate. From the bytecode, initially only you can generate the native code, binary code. So you can run a binary code directly also in Python. Means you can work like a C style, you can work like a Java style. Both are there. So depending on that, but in general, common process is C faster. Why we are using C in Java instead of C? Only faster is not enough. Brain also required, right? Vishnu Priya, only faster. Only faster. That is only one key feature. But many things are there which you don't have with C. Many things are there which you don't have with C. Java has, say, 100 things. Java, not only just oops. Oops means we have a C++, right? Oops means we have C++. Not just because of oops. Many things. Don't conclude now. Java has many things that you can't learn in a overnight. You have to learn throughout many things you learn on the way. So we have many things to learn in Java which are not there in C and C++. Okay, we have a Java interpreter and also JIT compiler is there. JIT compiler. We'll try to understand, and Java compiler anyway we have, right? So we know about a Java compiler very clearly. Java C.exe file. That is a Java compiler code, right? How you are compiling Java C space something. Java compiler will be used. You know the goals of Java compiler. And Java uses Java interpreter and Java uses JIT compiler, I am telling. But any idea about Java interpreter, JIT compiler? Back to the board. Okay, anyway, I'll explain. See that. Just want to check. Right. So we have, I have written hello.java, guys. Hello.java, I have written. This is my some number of code I have written, right? This is my source code. This is my source code I have written in this. So after this, what you have to do? Okay, guys. No need to type. Listen carefully. I'm going to explore everything in one simple diagram. After writing source code in .java file, what you have to do? You have to get a bytecode, right? you will get a hello.class file which contains the bytecode, right? Now, how you will get source code to bytecode? You have to compile it. So you need a Java compiler. Who is helping you here? Java compiler. What is Java compiler name? What is Java compiler name? javac.exe file, guys. It is simple file. javac.exe file. This is exe file. This is available in your JDK bin, right? JDK bin, we have a javac.exe file. This is your Java compiler. With that only you are compiling, right? How you are compiling? Generally, exe files, no need to write the extension exe. javac space your hello.java, whatever you write, you are writing that. So you are using a Java compiler. javac is a Java compiler and you are compiling it. Good. What are the tasks of Java compiler as we discussed already? Java compiler tasks, please. Number 1, check the syntax errors. Okay. Syntax errors. Number 2, code optimization. Very good, guys. You remember this. This is most important. Code optimization. Number 3, convert source code to bytecode. Very good. Convert source code to byte. That's it. Finally, everything fine. First, you check the syntax errors. If errors are there, it will display. If no errors, it will try to optimize if possible. If it will try to optimize if any chance is there. If no chance, nothing. If chance is there, it will change the code. Then finally, it will convert your source code to bytecode and creates the file called hello.class file. It will be containing the bytecode. Then when you run this, how you are running? For running, you can use a Java interpreter. When you're using Java interpreter to run this, what you are using Java interpreter? Java.exe file. What is Java interpreter file? Java.exe file, right? You are writing Java space hello. Right? Now, this is a java.exe file, which is available in same bin location of JDK. So what is the task of Java interpreter? Now Java interpreter is responsible for converting your bytecode to binary code and executing that. So here what it does, but it won't save the binary code anywhere. So this is your binary code generated. It generates the bytecode to binary code. When it is converting, what happens here? Very important, say this. Your Java interpreter converts bytecode to binary code line by line and executes line by line. It means if your bytecode contains, this is your bytecode, guys. Bytecode contains the 10 lines of code, right? 10 lines of code. So what Java interpreter will do is, it takes the first line, convert to binary, execute it. Again, go back, take second line, convert to binary, execute it. Again, go back to the file, take the third line of bytecode, convert to binary, execute it. Again, go to fourth line, convert, execute. So line by line conversion, line by line execution. This makes the program execution very, very slow. Very slow. When Java released first release of 1995, they internally used Java interpreter only. So Java interpreter is doing slowly, going to the bytecode, getting the one line, converting, executing, again going, taking one line, converting, executing, so slow. So then Java team has realized, oh, this is something doing very slow. Now we have to replace it. Then Java interpreter replaced with JIT compiler. Now what you have is JIT compiler. Oh, not here to write. So nowadays you are using JIT compiler to run your program. What is JIT stands for? Just in time compiler. Just in time, JIT, just in time compiler. Now how to run the program? Same guys. Java hello. So the file you are using is Java only. Java hello. Now you are using same. Olden days also you are using same. Then what is changed? The internal code of the file changed. Correct? Java.exe file was there from first version to now today Java 20 version. Java.exe file is there from first day to today. But previously, the file java.exe contains the code for Java interpreter style. Interpreter style code is there. So taking line by line, converting, compiling. That code they removed and written the new code of just-in-time compiler. What just-in-time compiler is doing, then why it is now after adding the just-in-time compiler for executing Java program, then program execution becomes bit faster than the older. So then what JIT compiler is doing? JIT compiler, instead of going, taking one line, converting, executing, it will take bunch of lines. Suppose if I have 1,000 lines of code in that, 1,000 lines of code in the byte code, it will go and get 200 lines first, 200 lines at a time, bunch of 200 lines, it converts and executes. Again, go and get another 200 lines, convert, execute. Again, go and get another 200 lines, convert, execute. So which is faster? 1,000 lines are there. What your interpreter will do? Interpreter will read the file, go to file, get first line, 1,000 times it will go convert, execute. But now what just in time JIT compiler will do? Instead of converting and executing the byte code line by line, it will do bunch of conversions at a time and execute bunch of instructions at a time. That makes the execution faster. That's what they replace the older Java interpreter with JIT compiler. Is that clear, guys? So now today, what you are using? Are you using Java interpreter or JIT compiler? You are using JIT compiler. That's it. The code is changed internally. You can't do anything. Clear, guys? So instead of line by line conversion, what it is doing here? Converts bunch of byte code at a time and executes that at a time. Makes it fast. Bunch of instructions, yes. Bunch of bytecode instructions, you can say. So from this diagram, what we understand? We understand about a Java compiler and its responsibilities, Java interpreter and how it is working, JIT compiler and what are the responsibilities of JIT compiler, how it is working. Is that clear? Okay, we've done that. These three things done. Next. Next, we need to understand what is JDK. We are using these terms heavily, right? JRE, JVM, JDK, JVM, JRE, right? These terms we'll explore with one small diagram. JDK, start with JDK. What is JDK? JDK stands for Java Development Kit. Java Development Kit. Kit is given. So kit contains everything, right? Kit contains everything. What everything? Development kit. So kit which contains all required for developing your programs, Java programs. Is that? What are there in this kit? Kit is a bundle. One bundle is given to you guys. In this bundle, what are there for you? Do you know anything in this bundle? In this bundle only your JRE is there, guys. Yes or no? You go there, you install kit, right? You already installed JDK. I'll explore it here from command line. Go to E drive. C2 JDK. Is that the kit you installed? Software you installed? This is the kit you installed, right? In this, what is there? JRE is there in this? Do you have a JRE as a part of kit? In this kit, JRE is there or not? Yes, kit contains the JRE. JRE stands for Java Runtime Environment. This is your JVM, guys. JVM is a logical name. JVM is a logical name. The actual software is given in terms of JRE. So JRE or JVM, both are same only. JRE coming as software and sitting in your computer, that is your JVM. JVM is a logical word we are using. Java runtime environment. Environment required to run the programs. Which environment is required to run the programs? Which environment is required to run the programs? JVM. That is your, okay. And other tools also there, I think, guys. Do you have other tools also? JDK contains all the tools. What tools are there? Your Java compiler is there in this tools kit only. JIT compiler is there in this toolkit only. And many other. If you want to create a jar file, we'll talk that later. Jar bundle, jar creation files, Java profiling files. See, bin folder contains the many utilities. Go to CD bin. Go to CD bin. CD bin. JDK bin. Put it dir. So you have many exe files under this. jar.exe file, java.exe, javac.exe, Java documentation. If you want to generate Java documentation, you can use this Java P profiling, Java W, WS. What else we use? Mostly that. When you're using RMI, this RMI technology almost outdated. We are means it is internally used. Spring may use this directly. We are not using it nowadays. RMI EJBs are almost gone. RMI registry. These are all other tools. Whatever you want to use, you can use it. Many tools are given under bin folder. So it is coming up with tools required to compile and run the programs plus your JVM. JDK contains all the kits. Is that clear? So JVM is actually a specification, guys. JVM is a specification given by Sun. I told JVM is a logical name, right? Logical name is they designed some architecture, something they visualized. Okay, JVM, something like this. It has to do this. It has to do this. It has to do this. Like this, some specification is designed. The specification implementation is the JRE. The specification is implemented. Means, can I say JVM is a document? JVM is a document, a specification document. Yes. Is it a software? No. JVM is a specification document. Maybe a PDF document or a Word document. They created one document. Designed, this is how it has to work. The real implementation, the software version of JVM is JRE. And here there are many JREs are there. Means the same specification, Sun has implemented their own JRE implementation. JVM implemented by Sun, called as Sun JRE. IBM has implemented their own JRE. IBM JRE. Oracle has implemented their own JRE. After merging Sun into Oracle, okay. But before that also, Oracle has their own JRE. Sun has their own JRE. Sun JRE is different. Oracle JRE is different. Understand, guys? So, did you get a picture? JDK is what, compiler is what, JIT is what, JR is what, JVM is what? Any clarification required on this? Or everything clear? Any questions up to this? Now, whenever we install JDK, automatically all the tools coming plus JRE also coming. Why different JREs? The company is implemented in their own. Only Sun JRE is the public licensed, free licensed, open source licensed is the Sun JRE. IBM JRE is not the open source licensed. IBM is taken this and improved their lot of performance improvement done internally, and they used in their IBM servers. Like IBM application server is there called IBM WebSphere. IBM WebSphere is based on Java only. It uses Java server, means for Java advanced technology, Java web server, for example. Now, IBM WebSphere is not using the JRE provided by Sun. They have done their own JRE called as IBM JRE. Same Oracle also, they have their own. Oracle has their own application server. So in their application server, like however IBM done, in their IBM application server, they are IBM using IBM own JRE. Similarly, Oracle has developed their own JRE. They named it as JRocket JRE. So JRocket JRE, Oracle has used in their application servers. This was done before Sun closed and Oracle acquired. Sun has its own JRE as public license. And these vendors, they have done their own JREs. Means they done more improvements. Whatever done in the specification, see under JVM specification, they have written, okay, this. Now IBM and Oracle, they implemented more better things internally. That they only knows, that is not a free. Only Sun JRE is a public. So why multiple different JREs? Clear. Next. Chandan, not cleared means what is not cleared? Ask your question. Clear, guys? Chandan, if you have any specific question like this point is not clear, you ask. If total is not clear, it is super good. After finishing the class, you listen the video and enjoy. What's the difference between JVM and JRE? Now, just now I told. What about other guys? What do you understand between JVM and JRE? JVM is a specification document designed by the sun. JRE is the implementation of JVM. No, Monica, you can't say that. JVM is a logical document. Logical name is a JVM. Logical specification document. Means physically no software. But what is the actual implementation is a JRE. They developed a software, guys. Software name is JRE. They're providing you as JRE software. That is actually nothing but a JVM, right? That only we're calling a JVM. You can say JVM is nothing but a JRE. Or super clearly I told, JVM is specification, which is implemented as JRE by one company, another company again implemented, same document implemented by different. Suppose, you see, I am going to send you one PDF document. Okay. In this PDF, I am writing one algorithm. I am saying that write an algorithm. Write suppose some algorithm, say what Prim's algorithm. Prim's algorithm explanation I am telling. Okay. I given a document. What is this? This is algorithm description. Now for this solution. Who is writing? Some student X is writing a solution. Student Y is writing a solution. Student Z is writing a solution. So for algorithm implementation, who has written? Algorithm implementation, who has written, guys? X has written one program, right? X has written a program, which is solution of the Prim's algorithm. Y has written a solution for the same program. Z has written a solution for a same. But what I have written, I didn't write any code. X written one code, Y written another code, Z written another code. Maybe their code is different. Giving solution answers. All X program works similarly. Z program works similarly. Y program works similarly. But maybe they have written a different code. But all will run same way. What I did, I didn't write any code. I given a specification document. This is the Prim's algorithm. Means in a graph, you do this graph, finding the shortest path or something like this. I explained that like this program has to work. I explained like a program has to work like this. It has to take this input, this graph, something like that. The specification document, what I have written on the Prim's algorithm, taken by student X, read on the program. Taken by student Y, read on the program. Taken by student Z, read on the program. Now, similar thing happened here. JVM is specification document. The implementation is done by some multiple companies. Now, can I say whatever implementation done, that is JRE is nothing but a JVM, right? Now, Sujita is asking again, can I run a bytecode with, okay. So, I think you guys have to remember in different way. So, whoever understand my, whatever I explained as of now, you make the difference. Now, when we install JDK, come back to this, another simplest version of explanation. You install JDK, Sujita. After installing JDK, along with JDK, what are coming? JRE is coming, right? Tools are coming like Compiler, ZZ, right? Whatever JRE software you are installing on your computer, this is the JVM, this is the JVM, this is the JVM. Clear? Remember, I try to explain so deeper, I think you are confusing. So deep explanation I'm cutting. Now, simply your JVRE software installed on your computer is the JVM. Clear now? Now I'll ask you the question, have we installed JVM in our computer or not yesterday? Have we installed JVM in our computer? Where we install JVM? Where we install JVM? where we install JVM under JDK, JRE. That is nothing but your. Samir is telling no idea. Superboy. Under JDK folder, there is a JRE folder. In today's session also I have shown. Go back to JDK. This is JDK 8.0. Put dir. See, bin is there. Lib is there. See, JRE folder is there. This JRE folder is there here. Samir, have you seen this? That is the JRE, right? Is that a JVM? Is that a JVM? Is that a JVM? Remember the simplest version. Remember the simplest version. This is your JVM. This JRE, nothing but a JVM. Clear? Right? Okay, guys. That's about. So I think all the terminology, whatever we have seen in the installation part, all we have done it. So one more, we have a Java profile. I'm going back to my D drive. There is Java P. You can give a dot class file name after Java P. Hello, I am giving. So it shows I am giving a bytecode. From the bytecode, it will bring the profile of the class. In that class, what methods are there, what variables are there, everything it shows. This is the main method we have written previously, right? Again, I'll do changes. I'll just remove this. I'll make this as our original line of public static, what we do daily. I'm compiling this program again. Java C space hello.java. Then Java hello is just for running and giving the output. You give Java P. Use a profile. See, in the hello class, whatever methods are there, only one method is there. Additionally, one constructor is there. This is the default constructor, comes automatically. We'll discuss that in the oops concept later. So profile of the class. In that class, what are the methods are there? What are the variables are there? Everything. For example, we have a string class. I think basic idea, Java P space string class available in lang package. We will study this later, no worries. I want to see in a string class, all the methods I have. What are the methods are there? Everything it is showing it. We will use a Java P later. Just remember, this we are using now Java P.exe file, which is there again in the bin folder. So because of setting the path, all the classes from the bin we can use anywhere, whenever we want. Right? So question from Lakshmi. In JRE we have JVM. No, in JRE, no. JRE is also called as JVM. Both are same. Clear, Lakshmi? Whatever the library is, I'm going to bin folder, JRE file again, go to E drive again. Under E, CD, JRE. I am in JRE folder C. Under JRE, you have some files. There is a bin and lib. So whatever the files under bin and lib, files under bin and lib, files under bin and lib are your JRE software, right? That is nothing but a JVM. JDK is a kit. JDK is kind of a suitcase. When you go to college hostels, if you are staying in hostel or when you go to your native place, you will pack all in your bag, right? You pack your kit, right? In your kit, you will keep your dresses, maybe if you study their books, then what else? What else? Maybe your other decoration items. This all you will pack into bag. You'll go home, right? Go to college, hostel, or go to maybe native place somewhere, right? Similarly, one kit bag is given. Kit is a bag given by Oracle. Now, in that bag is the JDK. In that, JVM or JRE is there. All tools like compiler tools, JIT Compiler, etc., etc., all the tools are packed in the kit. Right? Okay, guys. So mostly we are done with the part 1. And so we have seen the cases like I shown you the private JRE is there, public JRE is there. Actually, one JRE required, one JVM required for us to run the program. Okay, one JRE or one JVM required to run the program. But we have a 2 JREs installed. It means 2 JVMs installed for us. Public JVM, private JVM, or public JRE, private JRE. Can you tell where public JRE installed? Can you tell where public JRE is installed? Tell me where public JRE is installed. Public JRE. Navnita, I'm asking about public JRE. Srinivasdande, I'm asking about public JRE. Okay. We'll see that. We'll continue in the next session, guys. So what I'll do, we have an assignment 1 for this, right? Only this is our first module you are doing. First module related assignment, I will do for you. First module I will do so that you can understand. See, you learn many things now, right? You learn many things. Now, actually, you have to do the assignment of this particular module. But I want to show that if you do assignment, how you're going to recap the things and how questions will come. Maybe whatever I explained, there may be some questions which are asked in the indirect way, tricky way. So how you going to answer that? Just I want to show that. So first module is completed. First module assignment I will do for you in front of you. We'll do that in the next session. So in the next session, any other topics are there, we'll do, and we'll do the assignment of the module 1, which is Java introduction section. Okay, guys? Fine. We'll see the remaining in the next session.